All right, so let's get into the webinar. Our today's topic is a simulation strategy to understand material degradation. Right? What we're going to do is we're going to focus on material degradation and what goes around it. We're going to cover all the avenues around it. Like, okay, what kind of defects do we see based on the material degradation, and what are the causes of the material degradation? So we're going to cover the entire web, or at least try to cover, some of the highlights in different avenues around the material degradation. And just a quick introduction, I'm Harshal Bogezra. I have been in the simulation industry since last 9 years, and currently, helping clients who are frustrated by production problems like shrinkage, warpage, air trap, surface defects, and they're trying to understand, where is it coming from? Is it coming from, part design? Is it coming from the tooling, or is it coming from the processing side, right? So helping them on that side. And some of them are concerned by trial and errors on the production floor. So helping them through Moldex 3D. And I'm based out of Chicago area. So yeah, Midwest. And this is the overall agenda of today's webinar. We're going to go over a quick introduction of Moldex 3D. We're not going to spend too much time on it, and then mostly focus on shear degradation, shear thinning, the viscosity effects, what are shear stress and shear rate, and how you can evaluate through Moldex 3D. We're going to cover some recommended shear ranges and how to use them inside simulation and when you are interpreting some results. Shear-induced orientation. We're going to look at various defects, flow marks, tiger stripes, and also cover some of the, case study towards the end. So that's the typical, flow of our talk today. Firstly, why simulation, right? There are a lot of issues that we want to evaluate, like well line, right, air traps, flow marks, right, flow balance. We want to make sure that our cavities are balanced, our shrinkage and warpage is under control, and we are meeting our, dimension. We want to predict the fiber orientation and get an insight. Before we start molding the parts or before we make the tool, we want to understand, how the part is going to behave. So that's on the aesthetic side. And also to help you be more competitive, we want to reduce our cycle time, right? Whatever current cycle time you're running, we want to try to find out a way that, hey, is there any process out there that can even reduce my cycle time by like 3 or 5 seconds more,